Rational polynomial inequalities, pre-calculus, pre-college math. Write the inequality set for x cubed minus x is greater than 0. So the first thing we're going to do, and a lot of what we're going to do, is work in our calculators. So we type it in, and I'm going to type in to my y equals screen x cubed minus x. That's what it is, right? Yeah, x cubed minus x. Start off with my zoom 6. And I have to do what we've been doing. I have to find the roots. And so I can zoom in here to get a better picture of what's happening. And so I'm going to zoom in, and I'm going to zoom into the center. So I'll leave it where it is and hit enter. And I can really get a good view of what's happening in this picture now. Now this is a very basic example. Our roots are very simple. They're whole numbers. In fact, it's going to be -1, 0, and 1. You don't have to take my word for it. We can take a look at our table, and we'll see that they are there, -1, 0, and 1. And that really could be the first thing that you check, is check the table to see if they just happen to be there. If they're whole numbers, they will be. If they're fractions, then they won't be, and that's where you have to do the second calc trace with our friend Toodles. Move them over to the left bound, hit enter, and then move over to the right bound and do the double enter, and it'll tell you that root right there. You could also try factoring and things like that, but this is a basic one. And so what we want to do is we want to list them in a row, but we want to start with negative infinity because we know that's the extreme left. And then our first root is -1, and then 0, and then +1, and then positive infinity. I'm going to put that on my graph over here too. So here's negative infinity, and here's positive infinity. And so what we get is we actually get 5 intervals. We have an interval from from negative infinity to -1, an interval from -1 to 0, an interval from 0 to 1, and an interval from 1 to infinity. So I guess there's 4 of them. I think I said 5. So what I need to know is which of these 4 is the graph greater than 0, and which is it less than 0. And my answer is going to be the ones that are greater than 0. Remember, greater than 0 basically means above the x-axis. So above x-axis. If it said less than 0, then I'd be looking for the intervals below. So where is it above the x-axis? Well, starting at negative infinity, my graph starts, down here somewhere. And it's below the x-axis, below the x-axis, below the x-axis. When we get to -1, it then becomes above the x-axis until 0. So what we like to fill into these spots right below them is I'm putting a minus sign, a negative sign here, indicating that between the intervals of negative infinity and -1, the graph is below the x-axis, meaning it is negative. But between -1 and 0, it turns positive. It becomes above the x-axis there. Then it dips back down and goes back into a negative spot between 0 and 1. But then it crosses at 1 and goes above the x-axis again and stays there and travels upwards all the way to infinity. So it's this interval and this interval. So I'm going to write my final answer as parentheses, -1, 0, and I'm using parentheses because there's no equal to bar here. Otherwise, I'd use a bracket. We have our or symbol, parentheses, +1, comma, infinity. And infinity always gets a parenthesis no matter what. That's my answer. If the question had been a less than, then the interval would have been negative infinity to -1 or 0 to 1. I would have chosen the -2. Let me do one more example for you. Just get a quick time check there. All right. So let me type this into the calculator. Move it over so I can see it. We're looking at y equals 6x cubed plus 7x squared minus 108x plus 35. And I always like to start with zoom 6. Now I can see right away that there are 3 roots here, but it's going to be hard to work with this picture. So I'm going to try to see more of the curve. And in this case, I'm going to zoom out, but not in both directions, just in the y-axis. So you actually don't use zoom for that. You use window. And adjust the y minimum. Let's jump to a -100 and our y maximum to 100 and see if that helps us see more of the curve. And that's more, but still not all of it. So let me adjust it even more. Let's go to negative 150 and positive 150. It might even need more on the positives because it looked like it had more to go up there. All right, I mean, this is good enough. I could kind of tell what's going to happen here. If I wanted to see that little bit, I could probably make the x maximum, say, let's say 250, make sure we definitely get it. Oh, still not quite there. But anyways, good enough. And this will be a much better picture to work with when I'm trying to use totals and so on. So I said a good thing to do is look at the table first and see if you see any zeros in there. I don't, but if I scroll around, I actually do have one of them at negative 5, 0. So x equals negative 5 is one of my roots. X equals negative 5. And which one is that exactly? Well, if I take a look at my picture again, let me move this over. The negative 5 would be right here. So there's negative 5. So what are these other ones? They didn't show up on the table because I looked at the positive side of the table also. Get back to that table. And I didn't see any other zeros, which tells me they're probably fractions. So I have two options. I could do synthetic division, take out negative 5, and that'll leave me with a quadratic, which I can then do completing the square. Or I could just let Toodles do the work for me, and I'm going to do that. So second calc, 2, and I'm looking for Toodles here. There he is. And so this is my next spot. To the left of it is over here. So I'm to the left of it, hit enter, and then move to the right of the x-axis, double enter, and it tells me 0.3 repeating. But you need to know that 0.3 repeating is 1/3. So 0.3 repeating is the same as 1/3. If you don't believe me, type in 1 divided by 3. You'll see that 0.3 repeating. So x equals 1/3 is this one right here. It is positive 1/3. Kind of looks like it's close to that spot, but it's very close to the y-axis. But it is positive 1/3. And all right, so I'm going to do second calc 2 for my other one here. And let's get over there. A little bit more. Let's go to the left, enter, to the right, double enter, and 3.5. And 3.5 is equivalent to 7/2. So that's my other root, so 7/2. And so x equals negative 5, 1/3, and 7/2. All right, so let me list them out again. So I'm going to go negative infinity is the far left, negative 5 is the first one, then positive 1/3, and positive 7/2, then positive infinity. And what do I see happening in the graph? Once again, between negative infinity and negative 5, that's over here, it's negative. Between negative 5 and 1/3 over here, it's positive. Between 1/3 and 7/2, it is below the axis again, so it's negative. And after that, then once again, it's positive. It tends to follow this pattern of plus minus, plus minus. It does not always start negative. It could be positive first. There are cases where it's positive, positive, and I'll probably throw one of those exotic examples at you at one point. But so don't just assume it's that pattern. Make sure you do look and see if it does look like it's going below, above, like it is in this case. However, which ones do we want? We want the ones that are less than 0. We want the negative ones. There's a negative 1, and there's the negative 1. So I'm going to do in parentheses, negative infinity to negative 5. Again, parentheses, because there's no equal to bar. Or the other interval of 1/3 to 7/2. And that's going to be my answer for that one. So it's a lot of what we've done already, just kind of going a little bit deeper with it. So that's what we're going to get into, and we'll practice this on Monday in class. Have a great weekend.